Hello everyone and welcome to our video on solving quadratic equations part 2. In this video we're going to discuss how to solve a quadratic equation using what is called the quadratic formula. And then the interesting part is that part of the quadratic formula will help us to, even before we solve a quadratic equation, to identify the number and the type of solutions that a quadratic can have. So let's go ahead and get started. So let's just note that if we have a quadratic equation that is in the form ax squared plus bx equals c equals 0, okay, this form, there's a down and dirty solution in general to solve this quadratic, and it is called the quadratic formula, which is minus b plus or minus b squared minus 4ac divided by 2a. Take the square root of that b squared minus 4ac. I think I forgot to say that. Okay, so using this formula, and note the part that we need to also note is that this a, this b, and this c is the same as this a, and this b is the same as this b, and this c is the same as that c. So basically, it's a plug and chug. You just make a substitution. So let's go ahead and get started and take a look at our first example here. And that is, take a look at x squared plus 8x plus 15 equals 0. So note in this case, a is equal to 1 right here. B is equal to 8. And c is equal to 15. So the quadratic formula says we take x equals negative b, so negative 8 plus or minus the square root of 8 squared, b squared minus 4ac, so 4 times a, which is 1, times c, which is 15. Divide this by 2a. So clean this up, we get negative 8 plus or minus the square root, so 8 squared is 64. 4 times 1 times 15 is 60, divided by 2, and note that this is equal to negative 8 plus or minus the square root, so 64 minus 60 is 4, divided by 2. We know the square root of 4 is 2, so we get minus 8 plus or minus 2, divided by 2. So we get negative 8 minus 2, which is negative 10, divided by 2. So we get negative 5. Negative 8 plus 2 is negative 6, divided by 2. So we get negative 3. So these are the two solutions to our quadratic equation. Kind of nice, just down and dirty. So 8y squared plus 1 equals 4y. So let's just observe, because of the y squared, this is quadratic, but notice that it is not in this form here of ax squared plus bx plus c, so we have to put it in that form. So notice the only thing we have to do is subtract 4y from both sides, so 8y squared minus 4y plus 1 equals 0. So now we have it in that form, in the form of ax squared plus bx plus c. We can observe that a equals 8, b equals negative 4, and c equals 1. So let's recall the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and all of that's divided by 2a. So again, we make the substitution, so b, so minus a negative 4, plus or minus the square root, so b squared, so negative 4 squared minus 4 times a times c. All this is divided by 2a. Okay. Okay, so here we get 4 plus or minus the square root, so here we get 16. Let's see, what do we get here? 8 times 4 times 1 is minus 32 divided by 16. And this is equal to 4 plus or minus, so 16, so we get the square root of minus 16 divided by 16. And let's just note that the square root is 16, so we get 4 plus or minus 4i divided by 16. And to put it in the form that we need, so we get 4 over 16, so I get 1/4 plus or minus, and then 4i over 16 is 1/4 I. So our two imaginary solutions is 1/4 plus 1/4 I and 1/4 minus 1/4 I. So notice we can have imaginary solutions to kind of continue that discussion from our previous section, our previous session. Okay, so now I'd like to take a look at one more using the quadratic equation. So I'd like to take a look at 4x squared minus 16x plus 16, and this is going to equal to 0. So notice a is 4, b is negative 16, and c in this case is 16. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So make the substitution. So negative b, so negative a negative 16 plus or minus the square root. So b, so negative 16 squared minus 4 times a times c. All this is divided by 2a. Okay, so let's just observe that we get 16 plus or minus the square root of negative 16 squared is 256 minus 4 times 4 is 16, and 16 squared we just said is 256 divided by 2 times 4, which is 8. So here we get 16 plus or minus 256 minus 256 is 0, so root 0 divided by 8, and I think we can all see that this is just going to end up being 2. Okay, so this is a rather interesting sort of thing. Based on our solutions, let's just go back and observe that. Notice here I ended up with 2 real solutions. Let's just notice here I ended up on our second example of 2 complex solutions. And let's observe here that we ended up with 1 real solution. And the type of solution
I don't know that.
and what kind of solutions that we get is based on, and if you'll notice and come back over here, is notice that over here when we evaluated this component, I ended up with square root of 4. And notice that when I take the square root of 4, I end up with this real number. So I ended up with these 2 real solutions. So notice that this part here under the square root was positive. Let's just notice for my complex solutions, this thing here under the square root ended up being negative. And then let's just observe that this part here, when I subtracted, ended up being 0. And I ended up with 1 real solution. So this is always going to be the case. And let's just observe that it's all conditioned upon this thing underneath the square root. That is this thing right here. So that thing has a special name. So we call that the discriminate. So the discriminant is b squared minus 4ac. So the interesting thing to note is that if b squared minus 4ac, if this ends up being positive, then we will always end up with 2 real solutions. If this thing ends up equals 0, then we end up with one real solution. And if our discriminant ends up being negative, well, we don't get any real solutions. So 0 real solutions, but we get 2 complex solutions. So the discriminant tells us how many and what type of solutions we get. Okay, so let's just take a look-see at a couple of examples, and let's just not use the quadratic formula, but let's just use the discriminant to tell us the type and how many. So x squared minus 5 equals 0. So what do we get here? 9r squared plus 1 equals 6r. And then finally we'll take a look at our third one here, which is going to be 4 minus 3x plus 12x squared equals 0. So let's just identify the type of solution and how many that we get. Okay, so let's just observe that A equals 1, B equals 0, and C equals negative 5. So we have b squared minus 4ac. So b is 0 squared minus 4 times 1 times a negative 5, which is equal to 20, which is a positive number. So here we're going to have 2 real solutions. And that's it. That's all we do. So let's just observe that this one is not in our form, but we can put it in our form of 9r squared minus 6r plus 1 equals 0. So let's just note that a is equal to 9, b is equal to negative 6, and c equals 1. So b squared minus 4ac is going to equal to negative 6 squared minus 4 times 9 times 1. So we get 36 minus 36, which is equal to 0. So this means we are going to have one real solution. Okay, so as per our right here, equals 0, boom. Okay, and now let's over here notice that A equals 12, B equals negative 3, and C equals 4. If it helps, you can rewrite this as 12x squared minus 3x plus 4 equals 0, if that helps you to identify. So again, b squared minus 4ac. So we're going to get negative 3 squared minus 4 times 12 times 4. So here we get 9 minus, and here we see we're going to get a pretty big number here. So 16 times 12, 2, 3, 6, 1, 192. I think at the end of the day we can see that this is going to be negative. So we're going to have 2 complex solutions. Alright, I think you can see how down and dirty and nice and sweet using the quadratic formula is to solve quadratic equations. It's just a substitute, plug and chug, computation sort of thing. If you're interested in the textbook, you can see the derivation. And again, if you have any questions or muddy points on this discussion, please feel free to bring them to class, and or preferably throw them in your warm-up so I got an idea and we can prepare for them. All right, thanks a lot, and I will see you in the class.